Everybody in class knows how to find the molar mass of something. If I have a compound that's CH4, you just look in the chart. Carbon has a molar mass of 12, hydrogen is 1, so you have 4 times 1. The molar mass of this thing would be 16 grams per mole. That's not a problem at all. What we're going to do in this example is figure out the molar mass of an unknown compound. So I have no idea what the formula is, and we're still going to be able to figure out the molar mass. Now that's pretty impressive if you think about it, finding the molar mass without even knowing what the substance is. In order to do that, we have to use what we've learned about boiling point elevation and freezing point depression, or some of these colligative properties, to help us. So the problem here says I've got 25 grams of some unknown sample, some unknown compound, and I put in 155 grams of water. When that happens, the boiling point rises by 0.388 degrees Celsius. So I have my 25 grams of the sample, and this is my boiling point elevation. Here's what we're trying to find, the molar mass. Well, molar mass is simply the amount of grams we have per mole. Well, I know right here that I have 25 grams of it. So if I can figure out how many moles I have, I can divide and end up finding my molar mass. So, in this case, the information they give us is boiling point elevation. So I'm going to use this equation to solve for the number of moles, because moles is what I'm looking for. It says the boiling point rises by 0.388 Celsius degrees. The boiling point constant for water, again, you have to look these up. I gave that to you as 0.52 Celsius degrees per molal. And I'm going to actually write molality in terms of what that is. We know that molality is moles over kilograms of solvent. So I'm just going to plug that right in here, because moles is what I'm looking for, moles of solute. And how many kilograms of solvent do I have? Well, my solvent is 155 grams of water, which is really 0.155 kilograms. And now I have a simple way of just finding the moles. What I need to do is take my 0.388 and divide that by 0.52 to get the 0.52 gone. To get rid of my 0.155, I need to multiply both sides by 0.155 kilograms. So they're gone, and I'm left with moles of my solute equaling 0.388 times 0.155 divided by 0.52, and that is 0.11565. Once I know the moles, I can plug that over here, 0.11565. Take your 25 divided by that answer, and we end up with a molar mass of 216 grams per mole. So I have no idea what the compound is, completely unknown, but I do know that the molar mass is 216 grams per mole. What you could have done, I kind of like writing the molality as moles over kilograms. You could have just divided TB by KB to find the molality, and once you know the molality, use the molality equation right here and fill in the molality and the kilograms and solve for moles. To me, it's a little easier just to save one step. Pretty powerful.